Hello everyone, this is Shankar and welcome to another video. In this video, I'm going to talk about streams in Java 8. So let's jump straight into it. So let's suppose we have a list of integers. List. And let's call it numbers equals arrays dot as list. And let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 inside the list. Import it, and let's say we are trying to find out the even numbers inside this list. So before Java 8, we would have had to do this. For int num inside numbers, if so we are trying to print the even numbers, if num mod 2 equals 0, sys out num, right? And this would have given us the even numbers inside the list, right? And let's try to run this. Right, so we have the list of, or we have the even numbers printed, right? But with Java 8, what we can do is, instead of writing this this code, we could have written numbers dot stream dot filter, and we'd say num mod 2 equals 0 dot for each system dot out, and then print ln, right? If we do this, let's see what happens. Let's comment this out and try to run this line number 17, and see what happens. So it gives us the same result, right? So the problem with this code, the problem with this for loop starting from line number 12 till 15 is that if this list of numbers is a huge list, we have to do this processing sequentially. We cannot do it parallelly. And if we have multiple cores inside a processor, if our processor has multiple cores, then we would not be utilizing all the cores, or we would not be parallelizing the processing that we could parallelize. And that is one problem. And for iterating over this list, we have to write our own logic for iterating over the list. So we have to write this for loop for iterating over the numbers list. That is another problem with this code. And for executing a simple task such as trying to find out the even numbers in a list, we would have to write these many lines of code. So these are the problems with this code. And what Java 8 does is it gives us the stream method. So let's get into the stream method and see what is there inside the stream method. So this is inside the collection interface, and the collection list is a type of collection, right? The list interface inherits or extends the collection interface. So if we go inside list, this extends collection interface, and inside the collection interface we have this default method called stream. So what it does is it takes the elements of the list and converts it into a stream, and stream provides all these cool features that we can do with our elements inside the list or inside the stream. So we can do stuff like filtering, we can do stuff like finding the max, finding the mean, finding the average of numbers, and we can also do the skip limit. We can skip a few numbers, or we can skip a few elements and process the rest of the elements, and we can limit the number of elements that are processed or that are taken into account. So all this stuff we could do with SQL queries, and we could do with database queries such as limiting and skipping, and trying aggregate functions such as min, max, average, and stuff like that we can do with streams as well. So stream provides a lot of cool features to process the elements inside a collection, right? So that is what we are doing here. We are basically filtering out the numbers that are even and that are divisible by 2, and we are saying for each we are printing this printing the number, right? So let's take a look at the various some of the important methods that are provided for a stream. So we have all match. So this will take, and again this takes in a predicate, and in my previous video I have talked about the functional interfaces in Java 8, and if you have not already watched this that video, I'll link it in the description box below, and you can also press the I button on the right hand side top corner of the screen and take a look at that video and learn about functional interfaces in Java that have been provided in Java 8. So this all match takes in a predicate, a functional interface, and predicate basically takes in a certain type of input and returns a Boolean value. So here what we are doing is we are passing the elements inside our list or inside a stream into this filter, and we are taking each element and returning a Boolean whether that is true or false, and based on that the stream is filtering that element, and then we are saying for each. So let's take a look at this for each. So this is inside the stream interface, and let's just go up and take a look at the interface. So this is the stream interface, and it extends base stream, right? And we have this for each method inside the stream interface, and for each basically takes in a consumer. So consumer is again another functional interface, and consumer basically if we take a look at consumer, right, so it basically takes in a type parameter, and the type parameter is a type of input to the operation. So it takes in a type parameter and it doesn't return anything. So the accept method for consumer is a void method. It doesn't return anything. So what we are basically doing here is we are writing a method reference for printing the numbers that are even inside the list or inside the stream. So let's take a look at some of the important methods that we have for our stream, Java 8 streams, right? So we have match all. So this will take in a condition and try to match and try to see if all the elements inside the list match that certain condition or not, and based on that it will return a true or false. And match any will try to check if any of the elements inside the list or inside the stream matches a certain condition or not, and if any of the elements inside the stream matches the condition that we are passing in as the predicate, it would return a true. And then we have collect. So what we can do is for streams we can have maps as well. We can map the elements of a stream. So let's just try to do that and see how it works. So I'm going to say numbers.stream.map, and I'm just comment this out. And if we put our pointer on top of map, we can see this takes in a function, functional interface. So we have talked about function in a previous video, and again if you have not already watched that video, just go and watch it. And function basically takes in two type parameters, and the first type parameter is for the type of input to the function, and the second type parameter is a type of output for the function, right? So output of the function. And so it can basically take in a certain type of input and then it can return another type of output, right? So what we are going to do here is we are going to convert the numbers or the integers into a string. So I'm going to say num and integer dot toString, right? And we're going to pass in num, so that's going to convert num from an integer to a string, and we are going to collect these records or these elements, and I'm going to say collect, and I'm going to say collectors collectors dot toList. So that's going to give me a list of strings, and I'm going to hold it inside another list. So I'm going to say list of string, and let's call this string list, right? And let's try to print the string list. So I'll say sys out string list, right? Let's go ahead and run this. So we can see the numbers have been converted into list of strings, right? Let's just try to append something. So I'll say class hello, right? So that we can better understand that these have been converted to string. So we can see we have one hello, two hello. So hello has been appended after each of the numbers, right? Along with the space. So what we are basically doing here is we are mapping each element inside the stream. So first we are converting the list into a stream, and we get all the cool features of the stream component that has been added to Java 8, and we'll be getting all the cool functionalities or all the cool features, and we'll be having a list of functions available to us for processing the elements inside our stream. So we'll be using the map. We are using the map here, and what this map is doing is it basically takes in a functional interface, and we have written a lambda expression to implement the abstract method inside the functional interface. So what we are doing here is we are taking each of the elements inside the stream, and we are converting them into a string, and we are appending this hello word to that number, right? And then we are collecting each of these elements that have been converted from an integer to a string, and we're collecting them using the dot collect method, and we are saying collectors or toList to convert them into a list of strings, and then we are holding those strings inside the string list, right? And that gives us the list of strings, right? So let's take a look at the other methods inside a stream component. So we have all match, any match, then collect. Okay, we have count as well, so this will give us the count of elements inside the stream. We can have distinct as well, so this is a feature that we can use to find out the distinct elements inside our stream, similar to the database distinct that we have. So for database we have all these kind of features where we just write the syntax, write the script, SQL script or the SQL query, and it gives us all these functionalities, right? So we have similar functionalities provided to us with the help of stream component of Java 8. So we have distinct, and then we have filter. So we have already taken a look at filter here. We are filtering each of so let's just uncomment this, and here we are filtering each of the elements based on a certain condition. Again, filter takes in a predicate that is again a functional interface, and a predicate basically takes in a type parameter to indicate the type of input that it should accept. and basically this is taking in a number or an integer, and it is checking whether it is divisible by 2 or not, or is it is even or not, and based on whether it is even or not, it is returning the number, or it is returning an intermediary stream. And what we are doing here is we are saying for each of the elements in this intermediary stream, we just want to print them, right? So we are writing a method reference here to print the elements inside the stream, right? So let's take a look at the other methods that we have, or the other functionalities that are provided with stream. So we have count distinct, we have filter, we have find any, find first. All right, let's take a look at flat map. So let's suppose we have this list and we have another list. I'm just going to comment these lines out. And let's suppose we have another list. Let's copy this, and let's say numbers 1, and let's change the numbers a bit. So I'm going to say 67, 68, 69, 70, 71, 72, 73, 74, and 75, right? So we have two lists, and what we're trying to do is, and let's suppose we have another list, and this is a list of integers. This holds a list of integers, right? So this is a list of lists, and we're gonna call this list of list, right? Equals new array list, array right? And get the imports, and inside this I'm gonna add dot add. So I'm gonna add numbers, and I'm gonna add numbers 1, right? And let's first try to print this. So I'm gonna print list of lists, right? So let's try to print this and see how it looks. So this is how it looks. We have two lists inside this list, and let's suppose we want to flatten this list and make it into a single list. We want this list to be inside a single list instead of, you know, having a list of lists. So what we can do is we can use a flat map for that, and I'm gonna say list of list dot stream dot flat map. So basically what flat map is going to do is it's going to flatten the maps inside this map, and it's going to give us a single map, right? Or it's going to give us a single list. It's going to flatten the list inside, flatten the lists inside this list, and it's going to give us a single list, right? So I'm going to say list, right? I'm going to say list, and I'm going to say list dot stream. So that's going to give us the list of streams, and then I'm going to say collect, and collectors dot toList, right? And then we're going to hold this inside another list. So I'm going to say list of integers, and let's call this numbers 3, right? And let's try to print this numbers 3, and let's go ahead and run this. So we can see this list of lists has been converted into a single list, and it has been flattened. The lists inside this outer list have been flattened and pushed inside a single list, right? So if you're dealing with complex features or complex structures such as this one, we can use a flat map functionality of streams to flatten the structures and bring them down or reduce them down to structure that is more easily comprehensible, right? And let's take a look at the other features that we have, or the other methods that we have inside the stream component. So we have flat map to double, if we're trying to convert to double, flat map to int, flat map to long, and then we have is parallel. So we can parallelize the streams as well. So we can have parallel streams as well. We can use the multiple cores that we have for our processor and use them effectively. And we also have this dot parallel stream method, which would convert this stream into a parallel stream. And this method is parallel would basically return true or false, whether this stream indicating whether the stream is a parallel stream or not. And then we can also limit, as we can do for our database queries, we can just limit the number of records that we're viewing for streams as well. And map, we have already taken a look at map. We have the min max functionalities also, so we can just find out the minimum and maximum elements inside our list. And these functions take in a comparator, so we need to define a comparator, which is again a functional interface. And yeah, and then we have non-match. So if we can pass in a condition and this non-match takes in a predicate, so we can pass in a condition, and if none of the elements match that condition, it's going to return true. So we have that as well. We have dot parallel, so that's going to return an equivalent string that is parallel. And we have peak, we have reduce. So reduce can be used if we are trying to find the sum of all the elements inside our list or inside our integer list. We can use a reduce. We can use a reduce method to do so, and it takes in a binary operator, which is again another functional interface. So let's go ahead and do a reduce, right? So what I'm going to do is I'm going to work with the numbers 3, this list that we have just created. So I'm just going to comment these out. I'm just going to comment this line out, and I'm going to try to find out the sum of all the elements inside our list. So I'm going to say numbers 3 dot stream dot reduce, and this takes in a binary operator. So binary operator basically takes in 2 parameters. If you guys remember from my previous video, binary operators take in 2 parameters, and it returns the same type of parameter as the input parameter. So the input parameters are of the same type, and it returns a same type of output, right? So I'm gonna say a comma b, and we're just gonna say a plus b, right? So we're just gonna find out the sum of the numbers inside the list, right? So I'm just gonna print this. And go ahead and run this. So it gives us the sum of the elements inside the list. Now if you take a look, this is optional. Now we're going to talk about optional in some other video, and I'm not going to go into the details of optional and what optional means and why we have this optional thing or optional component in the first place. So I'm going to talk about that in a later video, in another video, and in this video I'm not going to go into the details of optional. So we can see we have the sum of all the elements inside our list, and we can use the reduce method to find that, right? So apart from the reduce method, we have the skip and then sorted. So if we use a sorted, it will just sort the elements inside our list. So let's go ahead and use that. So first up, I'm just gonna have a few more elements. So I'm gonna say 4, 3, 2, 5, 1, right? And let's try to sort these elements. So the stream dot sorted, and let's just remove this, and let's say dot for each system dot out and println or print, right? Let's say println, so that we have the individual elements in each line, right? So let's go ahead and run this, so we can see we have the numbers sorted. So we have 1, 2, 3, 4, 5, and so on, right? So we can use the sorted function or the sorted method to sort the elements inside our stream, right? And so those are some of the important functions or important features that have been provided with the stream component in Java 8. And that is all for this video, and I hope you guys enjoyed this video, and if you did enjoy, please give it a thumbs up, and thanks for watching.